5 albums, who cares? They took 43 songs. Now real quick, what's it say, very first sentence? The length of songs, not the length of albums. So it's all about the songs. What was the 5? It was a red herring. It's just telling you how they got it.
Divide the standard deviation by the number of songs.
Square root of the number, yeah. Yeah, good. And what type of sampling did they do? They randomly took 5 albums from the collection and took all the songs from each of those albums. Cluster, beautiful. There's cluster-picked songs. So the 5 albums is just the groups they took, and they took all the songs.
So that's going to be 1.33 over
Square root of 43.
Okay.
I like it. Whatever the hell that comes out to be.
0.066.
0.066. And what do they say?
0.022.
Well, they suck. It's too bad for them. Assuming this is right, this is square root of that, right? Double check that. Because that would be where an extra factor of 3 would come in. Okay.
5.282L.
I really don't know how they got it. But there's I love the typos in the answer key because it really helps me find those of you who are just taking the answers from the answer key. There are some typos, and that's one where there's a typo.
I had one that I was like, I did our problem right, but I always refer to the one before to make sure I'm doing it right. Because and I'm almost positive the answer was wrong because I was like, this is impossible.
And this is where you don't waste any time thinking you're wrong. You just check it with me or check it with somebody. Email me. I check my email decently regularly. Say, is this problem right in the book? And, you know, yeah. So the main thing to get from this is if I take a sample of size whatever, it's got to be more than 30 to make sure it's going to come out to be normal. And I ask about sample means, I take whatever the standard deviation is now for individuals and I divide it by the square root of the sample size. So on this problem, what did I have to do first? I had to figure out what the hell the standard deviation was to begin with before I can then divide it by the square root of 43. So I had to use this formula to figure out what that standard deviation was to begin with. Let me give you guys a couple things. And then we're going to make the formula sheet. I have the answer key for that sheet. It was on the back of something I gave out the other day, the central limit theorem practice. I don't know if I have any more of those with me. Here we go. Yeah, I got a couple. Oh, cool. I got more than a couple. Anybody need that? It's the one with the craziness on the side. If you weren't here last time, you're like, what the shit is this square root of n? Well, that's what we were talking about last time. Is that everybody? Everybody else has that? So on the reverse side from the colors is practice problems. So I have the answer key for that side. What's up? Okay. Everybody's going to get the answer key for you. I'm going to give it out to everybody right now. So on one side is the answer key for that. On the other side of that is a practice test that I also have an answer key for that you'll get later. So let me give this out. We'll do the formula sheet. Then if you want to, you can work on this. And a little bit later, I'll give the answer key out. And throughout the whole damn thing, whenever you want to, we can just do homework problems or whatever. The homework is roughly equivalent to 1 quiz. Homework great.
I did, because I'm worried I'm not going to get through all the questions I have today. I did everything, but I have so many questions, so I'm trying to figure out what I should prioritize.
I would say if there are any sections you haven't done any homework out of, that's your priority, is to pick some and do
I
them.
did them all, but I didn't get them all right.
I lost track. We'll see what happens.
I didn't understand lots of stuff in each section, so I was trying to figure out, do I focus on that?
I would pick out a few key problems that you really didn't understand, get those answered, and then whatever time is left, do corrections. Yeah.
Is this homework or is that homework?
This is stuff I'm giving out. That's new stuff. So, I mean, one thing you can do if you want to is to not look at this answer key yet and give those problems a try.
Actually, yeah.
So let's.
When she asked about the homework we did in the quiz, did you need all the homework combined equals one quiz?
Roughly. So it's like a percentage more than one quiz, yeah. So homework is worth less than people sometimes believe, but it will affect you. It will still affect you if you don't do it. So I try to find that sweet spot where, if you don't finish all of it because you got a lot of shit going on, then you're like I was in school. I didn't finish everything, trust me. So I don't want it to kill you if you still do well on the tests, right? But at the same time, if you don't do it, I definitely want that to affect your grade at the end because you didn't do something you were supposed to do. You with me? But if I make it work too much, people cheat like crazy, right? They still do. It's not really worth enough to do anything for you. To make it worth not enough, people don't do it. So it's like finding that sweet spot. All right, let's make the formula sheet, and then we'll just see what the heck you guys want to do. This test starts at chapter 4. Chapter 3 had its own little mini test. I just wanted to set it by itself. Chapter 4, of course, starts with this stuff here. Right?
4 through 7.
7. Good.
On our formula sheet, we're not allowed to label what chapter the formula's from, just the formula.
Yeah, just the formulas.
Okay.
Yeah.
I almost wrote chapter 4.
I'm with you. And then however you want to write this, if you want to write the variance, you just got to remember to take the square root, or you can write the formula with the square root in it. Do you see what I'm saying? What you cannot do is write next to this x line, x p of x line, x squared p of x, and then put L1 times L2. And, I mean, that's too much. You will lose points. Thankfully, nobody's gotten angry at me for taking points off, because hopefully you know you did wrong. But don't put too much on it. It's not fair for everybody else. Yeah.
Points for and or, that was kind of a little looking points between and it's multiply or it's up.
Oh, totally. That's a note. That's not a formula. If you disagree, then I'm sorry. You're wrong. Let me think. Oh, so that's it for the xp of x stuff. These are nice formulas because you know exactly when the hell to use them. When I give you x and p of x. Then we got the probability of a a binomial distribution. So this is this thing. The formula looks worse than it really is. I don't know if you guys remember that. Yeah, once you get it set up correctly. What really sucks is if you got this set up wrong, but you got the right answer, that's concerning. These are the best mean and standard deviation formulas ever. It's really cool if you could just take a step back and see why this makes sense. What was little p again? What was the idea behind that?
Success.
The probability of success. So if I make 60% of my free throws and I take 20 free throws, how many would you expect me to make on average? 60% of 20. So this NP makes total sense. This one, normally the standard deviation requires a little bit more math and is prerequisite for this course, so that one, but at least this one should make complete sense as to why it is what it is. Alright, so...
That bottom one is NPQ, right?
Yeah, NPQ. My Q's always look like weird E's or something. Is that better? I don't know. Oh, that is a Q in Jeffersonian. Jeffish. All right. Let's see. We got chapter 5, which is the continuous stuff. So we can put down there the mean for a uniform distribution, the standard deviation for a uniform distribution. Gather in.
We're not allowed to put uniform.
Nope. You suck, Jeff. Oh, remember, A and B should immediately tell you what are A and B. Smallest to the largest, right? So that should be a big clue. 12, huh? We had a discussion. I can bring, that one semester I brought the actual derivation that uses calculus, of course, to get there. So, I mean, I could send that out over email if you can choose not to look at it. Because I freaked a few people out when I brought it in. I'm like, you guys asked? And I love that question. You should be very curious about it. And maybe if you haven't taken calculus, you go, maybe I should take calculus, or maybe you won't say that. Once you take calculus, you're like, how did I do anything without calculus? Let me see, where am I? So that's chapter 5. And then chapter 6 is where we start doing this stuff, of course. We already have that on earlier. And you can also put down there that. Which one?
The second Z. What is the...
What's this say? I know you're talking about the second one. What's this say? Data point minus the middle divided by the spread.
Right.
Data point minus the middle. Sample middle, but who cares?
Oh, sample.
Divided by the spread. Sample spread, who
Okay.
cares?
Yeah.
Z-score never changes.
Sorry, I was...
Yes.
Can you read that bottom one? I think it's like x bar equals standard deviation divided.
Alright, so this is a subscript. This does not say sigma over x or something weird. This is sigma sub x bar. It's the standard deviation for the means. I desperately, someday this will make sense. Not in 4 weeks probably, but this one is when I ask individual people how old you are, and it tells me how spread out their ages are from the mean of everybody. This one tells me how spread out the means of groups of however many are spread from each other. However you need to look at it. Yeah, whatever sample, whatever group you took. So if I took 4 of you at a time and calculated your averages, this would tell me how spread out those groups are from the average of the groups. So that's why when I ask a question about a sample mean, I probably should use the standard deviation that works for sample means. Does that make sense? That's what the trigger is. You take a sample, ask a question about the means. Oh shit, I better use the right standard deviation. The one that tells me how spread out groups are. Okay, maybe. So again, this is a subscript, not a over X. It's a subscript. You guys cool with subscripts? They've already happened a few times. Remember this formula? Don't write this down. What's that formula for? Slope. And I love it when people first learn it and think it's squared or some shit. What is that little 2 mean? It's the second y. Which one's the second y? Whichever one you would call the second y. It's just a little subscript. Just means a certain y. So what's this? It means a certain standard deviation. The one that works for means. Okay, I like it. I think that takes us through everything. Yeah. Chapter 5. These are the really only the formulas that were new in Chapter 5. Chapter 6. Chapter 7. Is there any formulas you think I left out? Sure. Yeah. Yes.
What's the percentage that lies between z-squared negative 3 and positive 3? And it's 68 is one standard deviation, and 95, then...
99.7. That can definitely not go on this.
No, I know.
All right, I like it. All right, anybody else? Any suggestions on something I left out?
We're going to need to know, like, I don't know how to say it. You know, the 68%? We're going to need to know those things?
Yes. I love the face you. So what's the, for a normal curve, how much is within one step?
There you go.
68%. Within 2 steps? 95. And within 3? 99.7. Say again?
And we can't put that on our sheet. though.
No. No.
That's only for normal.
Only for normal. I love it. For any distribution, Chubby Dude works, and that's why he's a lot more vague. Within 1 step, there could be nothing. Ooh, thanks. Within 2 steps, there's at least 75%. See how it jives with normal? It says there's 95%. There's at least 75%. But I'm not going to make you remember Chubby Dude. Yeah. Poor little Chubby Dude.
Formulas for chapter 7.
Chapter 7 is really just, the whole idea of Chapter 7 is taking samples. Right? Central limit theorem, which means the larger your sample gets, the limit of that is it goes to the center. Right? That's one way to interpret central limit theorem. And the limit that your sample size becomes the population size, the center becomes the actual same center. They all agree at the mean. Yeah. Yes, so you can bring all the formula sheets you've done so far. If you lost points on one, or you maybe want to rewrite that one. I've had people just take the same one back in with everything still there. I'm like, holy shit, guess what? You lost those points again. Why would you do that? Yes?
So on the last one for the sample, that number is the whole number, not the sample size number, right? The n?
N is the sample size.
It is the sample size. Okay.
Because
Then why don't we put an S there? It's very confusing.
N is the size of the thing you're looking at.
That I'm looking at.
Yes,
Like
yes.
48 or...
So if I said the average height for all American men is known to be 69 inches tall,
Right.
and standard deviation of 2.5 inches, that's a lot of people, right?
Right.
That's just a known thing about your population.
Your sample-
And I take a sample of 72 people. Okay, N is 72 because that's who I'm looking at.
Yeah.
N is always the size of the group you are looking
I
at.
can't put S instead of N.
S is the standard deviation. Yeah. So you don't want to put S there. Holy shit.
Okay.
Okay. S is the standard deviation. That would mess you up a lot. Don't do that. Okay.
If I were to put instead of an S, just a standard
Yeah, can I do that? Because
Is that going to be the same thing?
Where are we at?
that one.
This one?
Yes.
Don't even write that if you don't want to. Good
No,
Lord.
can we write that by instead of putting an S, can we put a standard deviation symbol?
All right, let me, you ready? I'm going to put the standard deviation symbol. There it is. Because this is a sample. If you put that symbol, that's the population, right?
Population.
You can't.
standard
Yeah.
I know, I
So it's a
don't
z-score for a population, z-score for a sample. But see how these are the same formula?
know.
Beautiful. The more you realize they're the same formula, the less room you need to take up on your formula sheet. So we're going to learn some more z-score formulas. They're all the same thing. Your data minus the middle divided by the spread. Always. Always. Some of you guys are going to look at me like like I'm crazy. Or continue to. Because your z-score, we're going to get the z-score formula. It's going to be huge. You're going to say it's the same damn thing as always. And you're all going to be like, okay, this guy's obviously on something. For several things, maybe. Okay. Any other formulas you think should be? They'll put that one on there. You know, we haven't used that one yet. We're actually going to use that one later this semester. Oh shit! If you don't like lines, it's too bad. They're going to come back. Okay, so let's do this. Actually, it's totally what you guys want to do. So you could, if you wanted to, you could group up with people near you and try out the practice test, and I'll give out the answer key a bit later. If you got more questions on stuff, you can ask away. If you got something more specific to you, you can call me over.
Just a quick question. How many questions will be on the actual test? Will it be around the same, like 6? Just because it's like a lot of chapters, so I'm just curious how long it's
Whenever I answer a question, I count all the ABCs. So normally, I would say the test is about 25 total questions, counting all the ABCs. So I say 4, and they're like A through J. That's not 4. Yeah.
Can you do from the homework, chapter 5.2, A2L?
5.
5.2. Oh, yes. Yes.
All right. Oh. Let me catch up to the problem. Okay. So find that the time is more than 40 minutes. Okay. Has everybody got formulas? Have we got those? Yes? I got one question I want to do.
Oh, are we doing everything twice here or again?
So, you just asked me the question, I forgot. Okay. So you see how it starts off looking like what? What is this and what's this? This is number 80, 82, right? 82? In chapter 5, 82, L. Well, that problem starts off looking like this, right? 25 to 45?
Yes.
Okay. Part L says, find the probability time is more than 40, given that it's at least 30. Right? Is that cool? That's what L says. Oh, okay. Probability more than 40, given more than 30. Is that cool so far?
Is it L or R?
You said L, right?
Yes, should be the last one.
Yes. What's happening? So L says, find the probability that the time is more than 40. Right? What's happening?
I don't have the question, I have only the answer.
I think,
It should be last part.
Yes. Yes.
yeah, that's just a lowercase l.
Oh.
Yeah, yes. I'm doing the one you asked for. Whatever that is. L. So now watch. When I have a given in a uniform, I can discount what's up here that's too much for this problem.
25 to 30.
25 up to 30. So redraw it using only the part you're interested in. We know that, given that it's more than 30. So chop this much up. Chop. Now how tall is it going to be? How tall? Look at it. 1 over 15. Given that you're in this situation, what's the probability that it's more than... Oh, did I turn this around? Yeah, more than 40. Now it's just the area of that rectangle.
I think it's x is less than 40, given that it's at least 30, right?
Find the probability that the time is more than 40, given that it's at least 30. So it's at least 30. Find the probability that it's more than 40.
And how did you get 1 out of 60?
So before it was 1 out of 20, right? Because it was everything from 25 to 45, that's 20. now I know it's more than 30. So now it goes from 30 to 45, so now the height has to be 1 over 15.
Why can we change the f of x since we are just changing the x?
This is one way to do this. The other way to do it is to actually use the formula for a given, which is, to me, it's just too much work. But you can leave the picture alone, but then you have to use the formula for a given. Right? Then you'll have to figure out the probability of this and this divided up by the probability of this. That's the formula for the given. What happens when you're given information? What happens to the bottom of the probability? What happens when you're given information? So if I ask you, let's probably pick a king out of a deck of cards. That's going to be 4 out of 52. What if I say, given it's a red card? The bottom gets smaller, so it goes from 20 to 15, because I gave you information. Cool.
So am I assuming that this is for wrong?
It's not as useful because it's below the mean one.
Yeah.
They just want you to shade it in. That's right. No. But it started at what?
32?
30. No, it started at 12, didn't it? What happened? Show me your homework sheet. Try not to sign this because I didn't like the question.
Oh, it's 32.
Every fourth one.
Oh, I did all of them. I thought you meant between 32 and 60.
No. 12 to 32
I'm
every
just
fourth
going to
one.
leave them in. Is that alright?
This one. Just don't ask me a question about it because I don't like the way they ask.
Okay.
Oh. What's your name again? Everybody else not get their quiz back?